Hello everyone, my name is Antonio Martinez. I am a software engineer at Intel, and in today's video, I'm going to cover Edge AI deep dive with OpenVINO and EdgeX. In today's training, we are going to cover an introduction of Intel distribution of OpenVINO toolkit, what it is, some of the components of OpenVINO, etc. Next, we are going to cover Deep Learning Streamer or DL Streamer, which is a tool that we can use to create deep learning pipelines using OpenVINO easily, just using the command line. We are going to cover how to use it, different features of it, and then we're going to create a computer vision pipeline using the LStreamer. I'm going to cover how to ingest an input. In this case, we are going to be using a video file, how to use one of the pre-trained models from OpenVINO, how to do data manipulation, how to send data to MQTT, Kafka, or JSON file, how to do pre-processing and post-processing of this pipeline, etc. Next, I'm going to cover how to publish this inference data, in this case to EdgeX. We are going to see how to create an MQTT device service, how to publish the data from DL streamer all the way to EdgeX, how to visualize the data, how to integrate this data with other sensors and create business applications. And lastly, next steps. How can you enhance this application with more sensor data such as audio, RFID, etc. Okay, first let's talk about Intel distribution of OpenVINO toolkit. Let's have an overview of that. What is OpenVINO? OpenVINO is a tool to run high-performance inferencing at the edge or at the cloud for deep learning use cases. If we go to the website here, how it works. So you simply train a model using a popular open source framework such as TensorFlow, PyTorch, MXNet, etc. Once you have your model, then you use the OpenVINO Model Optimizer, which will convert the model to an intermediate representation, which means the model is now optimized to run on Intel architecture. Once you have the model already optimized, then you deploy your model, your application on different Intel devices such as CPU, GPU, VPU, or FPGA. For this particular training, we're going to be using three components of OpenVINO Toolkit. The first one is the inference engine. This inference engine is the core, the heart of OpenVINO, is the one that is in charge of doing the inferencing, the heavy workload for deep learning use cases. Next, we are going to be using one of the pre-trained models from the OpenVINO Model Zoo. What is the Intel OpenVINO Model Zoo? Well, the OpenVINO team offers many models that are already pre-trained and they are open source, so anyone can take them and build demos or applications on top of that. If we go here to the website, this is the GitHub repository. You go to models, Intel, and you will find many different models for different use cases. So we have models to do face detection, we have human pose, we also have person detection, vehicle detection, text recognition, etc., etc. The third component that we are going to be using is the DL streamer or deep learning streamer. This tool is to create deep learning pipelines for computer vision or audio using command line. So it's very simple to create a pipeline using the L streamer. For this particular training, we're going to be focusing on this tool. Now, once you have your model, you use the inference engine to do inferencing. We're going to be using DL streamer to create this pipeline, very simple. All these are part of the OpenVINO toolkit. And now we are going to be sending the inferencing data to a user application. Next, let's talk about Deep Learning Streamer or DL Streamer. Let's have an overview and then a deep dive into this tool. First, what is DL Streamer? DL Streamer is a streaming media analytics framework based on GStreamer. GStreamer is an open source tool that is used for video processing and creating media analytics. Deep learning is a GStreamer plus OpenVINO, and we will be using all the benefits and tools from GStreamer for video processing, and OpenVINO will be adding the deep learning capabilities to it. The LStreamer enables developers to create deep learning pipelines. It could be audio or video across Intel architecture at the edge or cloud. As I mentioned before, for Intel architecture, we can use CPU, could be i5, i7, i9, Xeon. We can use the integrated GPU or VPU and FPGA. This is a simple example here on the right side. Basically, using just commands, we can concatenate or pipe multiple functions and just create a computer vision pipeline just like this to do face detection and emotions for this particular example. Now, let's switch to the website. This is the official GitHub repository for DL Streamer. Here you will have all the prerequisites that you need. In this case, you need Intel processor or graphics or more videos, the software, and we have getting a started guide. To install DL Streamer, we have multiple options. The first option, DL Streamer comes inside OpenVINO. So when you install OpenVINO, it already includes DL Streamer. So you can simply download OpenVINO and install it on your local host. The second option is using Docker images. OpenVINO offers official Docker images on Docker Hub. So you can just simply pull those images and run OpenVINO, which will be including DL Streamer as well. If you want, you can compile DL Streamer from source code or create a Docker image from scratch. You can also find tutorials to create simple object detection pipelines. Next, let's create a simple media processing pipeline using the LStreamer to do person detection. The first command that we need to execute is gst launch 1.0. Next is the input source. If we use this command, file source location equals the path of a video file, we will be using a video file as the input. We could also use a webcam as the input or RTSP path for an IP camera. Next, we will be adding this exclamation mark. With the exclamation mark, we're basically saying to DL streamer that from the previous command, in this case, the video source, take the output and send it to the next command. The next command will be the code bin. This command is included on the GStreamer and is simply to decode the input file and create or generate raw video frames that can be used for image transformation and also inferencing. Next is VGA detect. So the output from the decoded raw video frames, we will be performing inferencing using this command GVA detect. Then we need to specify the model for detection. In this case, we want to do person detection. We will be taking one of the pre-trained models from the OpenVINO model zoo. Just to mention, when you optimize a model using the model optimizer, or if you take one of these models from the OpenVINO model zoo, they are two files. One is an XML file and another one is a .bin file. For this DL streamer, you need to specify the path of the XML file and the bin file needs to be next to it. Next, we use the VGA watermark. This command will be taking the output from the detection and it will be drawing the coordinates or the bounding boxes on the video file. And then we want to display the post-process image or video on the Windows graphic environment using the XVImageSync. If we run this command on our console, the output will be something like this. We will be using this video file and running the person detection model against all these frames. If you need video clips for demo purposes, OpenVINO also offers video clips for multiple purposes on github.com. Here on github.com, under the Intel IoT Dev Kit account, we have a repo called sample videos. So we have multiple sample videos, video clips that you guys can use for demo purposes. So we have videos for car detection, face demographics, bottle detection. And for this particular sample that we just run, we're using this people detection video clip. Okay, let's run this sample pipeline on my local host. I already have OpenVINO 2021 installed on my local host, which includes DL Streamer. The first command is gst launch 1.0, then file source location, and then we choose the path of the video for our input. Then we decode that video into raw video frames that can be used for inferencing. Then we use the VGA detect, and then we choose the path of the pre-trained model from OpenVINO. We do GVA watermark to draw the bounding boxes on the frames, and then we display it. This is the video that we are going to be using as the input. It's just simply people walking around here, 2, 3 people. When we run this pipeline, we should see something like this. Now OpenVINO is performing the inferencing and doing the person detection and drawing a bounding box around them. Now we should see 2 people walking and so on and so forth. This is a list of the different elements that you can find inside the DL Streamer. These first are for inference elements. We already saw the first one, which was GVA detect. This is to perform object detection using models such as face detection, vehicle detection, product detection, etc. The next one is GVA classify. This command is used for classification models such as age and gender, vehicle attributes for color and type, etc. The next one is GVA inference to run deep learning inference using any model with an RGB or BGR input. The next is GVA audio detect. You can use this command if you want to perform audio events detection for speech recognition, for example. And the last one is GVA track. With this command, you can perform object tracking using zero-term or short-term tracking algorithms. The next set is for metadata processing. GVA meta aggregate, GVA meta convert, and GVA meta publish. We use these commands if we want to extract JSON objects, JSON messages, and send them over MQTT, Kafka, or a file. And the last commands, GVA Python, you use this command to provide a callback to execute user-defined Python functions on every frame. This is to do pre-processing or post-processing operations. We already saw GVA watermark to draw bounding boxes on the frames and GVA FPS counter if you want to know the frames per second. Okay, now let's take a look at a more complex pipeline using GVA classify. For that, we navigate into the OpenVINO samples for DL streamer. So when you download OpenVINO, they will come with some samples and pipelines already pre-built for you to test. So you go to OpenVINO 2021 data processing folder, DL streamer, samples, GTH launch, and then here we have one called face detection and classification. Inside, they have some scripts. Let's take a look at that script. So the important thing here is, well, the input. The input, we're going to be using this video file as the input. So I'm going to play it just to give you some idea of what we are going to do. Here we have two person that they are moving their head. So we are going to perform face detection, head pose, age, and gender classification. If we take a look at this script down here, or actually here, these are the models that we are going to be using. Face detection, age and gender recognition, emotions recognition, and landmarks. So how can we use and pipe all these models together? So let's take a look at the pipeline here. So we have GST launch 1.0 as we know. We have the source element, which will be using the video that I just showed. The code bean, we already know that. And GVA detect, we already know that. That is pointing to the face detection model. The device, where do I want to run this model? On CPU, GPU, VPU, or FPGA? In this case, device is set to CPU up here. Queue. This queue is meant to create a new thread so you can make your pipeline more efficient. Okay, now the output of this face detection you need it for the next model, which it's going to be um, in this case Let's see, class model here, age and gender recognition. Okay, so once you detect the face, then let's do GVA classify, because we are going to be using a model that is meant to do classification, in this case, age and gender. The output of that will be needed for the next one, which will be again GVA classify, and then the next model, in this case, emotions, and lastly, landmarks. So when we run this script, this is what it's going to be. So we have these two person, we have the age here, gender, female and male, and then right now they are both showing as neutral. Um, Now happy both. We can see some FPS, etc. So that's pretty much what you can do with the LStreamer and GVA classify. Now let's create a more complete computer vision pipeline with the LStreamer. Building a complete pipeline. First, we use the previous commands, gst launch 1.0. We use the file source location for a video file. Then we decode the video file, and then we use the GVA detect command to perform person detection. Now, the next command that we want to use is GVA meta convert. This command will take the output from the GVA detect and convert that output into a JSON object, a JSON message. What are we going to do with that message? We will send that message over MQTT. For that, we use the GVA meta publish command. We specify the method, in this case is MQTT. We specify the address of the MQTT mosquito broker. In this case, we use 127.0.0.1, which is localhost without a specific port. And then we just choose a topic. And lastly, the same command as before, GVA watermark and XV image sync to draw the bounding boxes and then show the post-process video on the window. So this is going to look something like this. We have the DL streamer person detection pipeline that we just created based on those commands above. This is going to generate the following JSON message. As you can see, we have objects attribute, which has an array, and we have the detections. In this case, we only have one. We will get information of the coordinates with x max, x min, y max, and y min. The confidence, which is how confident is that this object is a person. In this case, is 0.8. In other words, 80% or 86%. And some other data, resolution, timestamp, etc. With this message, we want to send it over MQTT Mosquito Broker. With this, we have a more complete pipeline, now integrating the output of this CV pipeline into MQTT Broker. Okay, let's expand the pipeline and now let's publish the metadata over MQTT. First, we need to run MQTT Mosquito Broker. For that, we can use the public Docker image, and we can run the following command: docker run -d -rm. We need to map the port with our local host, and then we choose this image. Now, if we do docker ps, Mosquito Broker is already running. We can use this MQTT FX client so we can connect to it. Here, we already connected. Now, let's copy the DL streamer pipeline from before. And the only difference here is these two lines. The first one is GVA meta convert, which will take the output from the previous pipe and create a JSON object, use that JSON object, and then GVA meta publish will publish that inferencing data over MQTT using this topic. So let's copy this topic into our MQTT FX, which here I'm already subscribed to it. If we run this pipeline, now we see metadata coming over MQTT. We have 42 messages. Let's wait until we have more people on the scene. Here, now the messages are increasing. These are all the detections that are happening on each frame. Containerizing the pipeline. If you are familiar with Docker containers, you can use the official Docker image for OpenVINO, which includes DL streamer. So if you want to run the previous command inside a Docker container, this is what you need to do. First, you do docker run and then interactive terminal, and then you pass the environment variable for your display. Then the commands in green, you are mounting volumes inside the Docker container. In this case, you are mounting the X11, you are mounting the video file, you're mounting the model, and then some scripts if you want for the GVA Python command that we are going to be looking into details later on. And then you just select in blue the Docker image for OpenVINO, in this case using the Ubuntu 20 version. And then lastly, you just execute the bin bash command. This will prompt you the terminal inside this container, and you just can simply execute the previous command that we just saw for DL streamer. How to integrate with EdgeX? Now that we have our DL streamer person detection pipeline already Dockerized, how can we publish that metadata to the EdgeX framework? So that is the question. In the next slides, we are going to cover how to register a MQTT device and how to publish data through it. Publishing inference data to EdgeX. The first thing that we need to do is to run the EdgeX framework. In this case, we're going to be using EdgeX 2.0 Ireland version. Once we are running EdgeX, we need to register a MQTT device service. So this can be done by default if we just include the EdgeX MQTT device service. This will register an initial MQTT device. We can use that device to publish some data. Now we have our DL streamer person detection pipeline, which is running outside of the EdgeX boundary. We need to send the metadata, the inference metadata that we are generating through the MQTT broker that is included in the EdgeX ecosystem. Now, something that I need to mention is that EdgeX requires a specific schema if we want to send data through MQTT. If we send any other schema, it will just get ignored. So we need to do a step before we send the data to EdgeX. On the left side, we have an example of the schema that EdgeX requires to start accepting MQTT messages. For example, we have here name, and then you need to specify the device name that is already registered. Then you have a CMD. In this case, we can call it inference data. Then we name it again inference data equal. Now here is where you put your data. In the inference data attribute, we just include the metadata that the DL streamer pipeline is generating. So in the next slide, I'm going to show you how to connect this pipeline that we just created into the EdgeX network. So joining EdgeX Docker network. So this is the previous Docker command that we created. In order to communicate with EdgeX, we need to join the EdgeX network. So we just add this line into the command, which is dash dash network, and we specify the EdgeX network that was created. You can do Docker network ls, and it will list all the different networks that you have. Then you just find the one for EdgeX and you specify it here. Customize the LStreamer pipeline. As I mentioned before, in order to send the data to EdgeX, we need to modify the schema. In order to do that, we can use the gva python command that allows you to run a script and manipulate data from every frame before publishing it. So for that, we need to create a very simple Python script that we can manipulate the schema of the JSON object before sending it over MQTT. On the right side, we have an example of this Python script. So we simply loop through every frame message. We delete the message because it doesn't have the schema that we need. Then we create a new object with the schema that is required for EdgeX. Create that schema into a JSON object, and then we add that new message to the frame. Then DLS streamer will take this new schema, this new JSON object, and publish it over MQTT. Now, pay attention on the gva meta publish command. If we run this command, if we run this pipeline inside the Docker container that is already joined into the EdgeX network, now instead of 127.0.0.1 URL or IP address, we need to change that to the MQTT broker host name that is for EdgeX. In this case, it's called EdgeX-MQTT-broker. Query inference data. Now that we have ingested the inference data through EdgeX, there are many ways to extract that data. One of them is to do a RESTful call. In this case, we can use Postman or any client that you want. We're gonna be doing a get command to this specific URL. If you are running EdgeX on your local host, you use localhost, then this port, and then the following path. In this case, we're saying reading all. So all the messages that you ingest to EdgeX, they are called readings. In this case, I want to query all the readings that we have ingested so far. The output will be something like this. We have an array of readings, which each object will be one of the readings that we published. If we see here, we have device name. This is the device name that we are using as default. And down here, we have value. If you pay attention here, this is the metadata, the inferencing data that our DL streamer pipeline generated. So this is where we will be storing the values. Okay, Let's put everything together. Let's launch EdgeX Ireland. Let's create our pipeline inside a Docker container and then communicate with EdgeX. First, I already have here a Docker Compose with all the EdgeX services. One way to obtain this compose file, we can go to the EdgeX Foundry GitHub organization and then go to the EdgeX Compose repository. You can clone this repo and then go to the Compose Builder folder, and then we have some commands that we can run. The usage here is you do make and then you choose one of the services to be included on the main Docker Compose. In this case, we will need a few of them. First, we need the device service MQTT, and also the MQTT broker. And for some data visualization, let's also include the UI. That will generate the following compose file. The only thing that I had to change for the device service MQTT is the following. This is the line that I added. We do MQTT broker info underscore host. So we're going to be using the EdgeX MQTT broker hostname, which is the MQTT broker here that is running already. So if we do docker compose -f docker compose EdgeX YAML file up, we will have everything up and running. Once we have EdgeX up and running, one way to uh, make sure everything is running correctly, we go to our web browser and we navigate to the following URL, localhost and then port 4000. This is the UI for demo purposes. To make sure everything is correctly, we have devices here. It should say 1. If we click here, we should have this MQTT test device. This is an MQTT device service that is going to be registered by default. If we have Postman and we execute the following URL, we do a get post, everything should be empty, no readings. So we have a fresh installation of EdgeX. Now on this other console, let's take a look at the name of the Docker network that was created. In this case was Ireland underscore EdgeX network. So we will need this to create our DL streamer inside a container and join the EdgeX network. Then we need to create the container. Let me just copy and paste that command over here. This will run and join the EdgeX network. I'm mounting my display, X11, the folder videos right here, the folder person detection with the models, and the script that we need to modify the output of the schema that we want to publish over MQTT. We run that command and now we are inside the Docker container. Inside this Docker container, now we can execute our DL streamer pipeline. Here, everything that we already know. We have GVA detect pointing to the model. Then we convert that over JSON and we execute GVA Python to modify the schema. And then we publish that schema and message over MQTT. The difference here is that, again, we need to modify this now to point to the EdgeX MQTT broker. We run this command and it will show the same video and performing the bounding boxes. Now, let's take a look at the Postman and re-execute the get command. Now we see some data flowing. If we go to the UI, we go to Data Center, Greetings, and we click Start, it will query the same API and it will be showing all the metadata, the inferencing data that is coming through this specific device service, the MQTT test device. We go all the way to the right side and then the value, all the object detections. Again, we execute here and then we have more data. Now this is how we can communicate and create a DL streamer pipeline, modify the data that is coming through MQTT, so EdgeX can accept it and be stored on EdgeX core services. This data can be consumed or extracted by any applications on the application layer to run some business logic. And lastly, next steps. For next steps, you can do data fusion with a second pipeline. As I was mentioning before, you can create a second DL streamer pipeline. In this case, you can do vehicle detection. You can use any other model and then ingest that data through EdgeX. You can also do data fusion with audio. DL streamer, as I was mentioning before, it also supports audio. So you can do speech recognition, for example, and send that data through EdgeX. Now you can create a more complex use case. For example, you can do face detection and then speech recognition and maybe do something around fast food restaurants where they have this menu dashboard and instead of talking to an employee to get your order, now you can implement a AI solution where you can detect the face of a customer and then using a speech recognition to get the order. Now you are um, fusioning these two data to solve that problem. And lastly, you can build application services using EdgeX application layer so you can add business logic to your solutions. Thank you. Thank you so much for your time. If you have any questions, I'm going to have all the resources and the links in the next slides.